Hi everyone, yep, it's Dale Pendragon, finally going to unbox and build the Eryone ER-20 that I was sent as part of the 6th anniversary of Eryone and their time in making 3D printing equipment. So I'm going to bring this out a little bit at a time. But you can see here that it comes with a quite nice little thing. There's some sample filament. Looks to be PLA. Have a nice little set of instructions to put it together. And a very old school, thick manual. Something we don't see that much anymore. It's more like quick assembly guides, and then the rest is literally get the PDF online. So let's just open that up. This actually looks quite nice, actually. Nice all metal design. That nice ink bed that they were talking about. So what we're going to do, so that I have plenty of room to work, because as you can see my office is not really that big, I'm going to move the box off to the side so that I can work on this little table that I have. They do have a YouTube link, so in case you're curious, I do have a YouTube link here for assembly. Looks pretty straightforward. Yep, okay, so you do have to install the lead screws, obviously yourself. That's not too bad. But, yeah, okay. So let's go ahead and get building. So, bring this over here. Put that filament up there. There you go. Chair there where it's not going to fall off onto the floor or knock the camera off into an angle that's bad. Wow, that box is so big it will not even fit in my chair. Okay, so let's put that over here and we'll bring it up a piece at a time. In case any of you are wondering, these bags are where I save parts of prints that would either fail or supports. And I obviously send them off for recycling to a gentleman in Scotland who has been turning them into various things like clipboards and such as that. Bag for PLA, for example. There we go, that's better. Okay, so let's go ahead and break that open. And I can more fit this when I need to. Okay, just getting out that. There we go. That's our print head. Obviously, that actually looks like that fan shroud is injected and molded. And in case anybody's been curious what the print heads on those look like, there you go. It does look a little special. Bolts on the top. But that does mean there might be some opportunities. It does appear to be PTFE all the way to the nozzle. That looks to be plastic on the extruder, but at least it has an in and an out, so that's good. So I'll put that over there for the moment. Let's get this power cable. Put that up here. Yes, probably not the most professional of studios as per se, but it's my hobby shop as per se. And I predominantly do this for me. For me, this is exactly what it is. It is a hobby. Okay, I like the size of this. It's not overly big, but it's not overly small either. The fact that the whole thing fits on a TV table, that's pretty amazing. Yeah, Looks like those are already pre-installed. Yep, that's pretty good. I'm going to get those because I'm kind of like OCD like that. Okay, so inside of here, we got the rest of our little bits. So we got some spare parts here, obviously for refurbishing certain aspects. These are actually for the belts, in case you ever have to redo your belts. There are printable options for that. Okay, that's a very small spool holder. I believe that probably will work because that is just a couple of bolts and that feels like metal. Okay, so that'll actually probably work. Some people prefer something that has rollers, so I might end up doing that. Ah, SD card, yes. Yes. Just remember, no rude jokes about that one, okay? But yeah, you got your SD card and the control knob and a USB card reader writer, so that's good. Open that a bit further. What else we got here? Some tools. Tools are always good to have. Never can have too many of those. That obviously came off of the spatula. There's all our nice little tools. Quite a good little selection there. Nice little thing for getting your prints off the bed. And it's not been sharpened. I usually end up putting a little edge on those, but that's just me. And then these are your bolts and bed clamps, obviously for holding the glass bed on, obviously when it's moving. So that's all right. So let's put this like that. Leave the spares alone where they are. They do also appear to have a spare nozzle, and it looks to be coated. So obviously it's going to be brass, but it probably has a coated nozzle. That's nice. Nice long nozzle needle. So if you need to clear your the nozzle in it, you have one. That's nice. Right, so parts, obviously toolkit. Spares can stay in the box. And of course, control knob. Yes. Yep. Eryone packing list. This explains something because we had somebody that was asking what these were in the group on the messenger, on the Eryone messenger chat. And that explains what this is. So there was somebody that had received from their local grocer that was selling box lots of lost parcels and such. And it turns out they had a ton of these, and now I understand what these are. So you got your screws, your SD card kit, basically all the extra things. Extra gift. What would be extra gift? Those are the spares. I'm curious what the extra gift would have been. It must have been one of the things in the bag, and I'm sure I'll come across it. Okay. That's probably what it is. But, yeah, okay. Still useful tools. Now, box, and I'm going to guess that somewhere in here there's a hidden glue screws. Ah, they were underneath the toolkit box. There they are. I figured they wouldn't be overly tall. This is the type of printer where if you want to extend the height, there's a little bit involved, but you could do it. There we go. Some nice lead screws. There we go. Oh, doesn't everybody just love this packaging wrap? There we go. Starting to get there. I know. Get a knife. Got it. No. Rather do it the hard way. Okay, I'll get a knife. There we go. Okay, so yeah, obviously typical 4-start lead screw. That would make it a TR8X8 lead screw. For those that don't know, obviously your others are TR8X2 and TR8X4. The X4s are the 2-start, and your TR8X2 is your single start with a 2mm pitch. Not too many of those anymore, but these are typical of the Ender 3, so they're obviously, if you end up with a bent one or something happens and you damage them in some way, or over time you haven't been lubricating and they wear out and start getting a bit rickety, you can get these on Amazon. These ones are probably within the range of this. Nope, need a bigger, slightly bigger ruler. Let's put that back out. Yeah, I actually have a bunch of magnets up top. So lead screws are, let's get that right up there, 330mm. Nope, my finger on it where it's flush. 327mm. 327mm lead screws. Very nice. Okay, right. So moving along. And of course, obviously, before I go absolutely crazy, SD card's an 8GB, in case you're curious. So obviously doing that. There we go. The lead screw is on. Typical bulldog clips. Now let's see, what do they have? Yep, there it is. Piece of foam holding it in place. It's good because it keeps you from having it shift around in shipping. Obviously causing the motors to generate a voltage and ultimately kill your main board. Now this is interesting because this one's missing the top bit of the clip. So that's quite interesting. It's a good thing though, however, that I have somewhere, there they are. I have a bunch of these from Once of a Day when I used to use a glass bed. In fact, I'm contemplating, because I recently got hold of some glass from something that was reclaimed. There we go. A couple of nice bed clips. As you saw, dead center, directly above where the belt is. So you can see here, idler here, belt there, obviously right in the middle. That's all you need to hold a bed in place. Yeah? Now, let's see how they did this. Okay, take that to the bed. Oh, no, okay, it's just that. Wow, that's pretty. Now, that is an impressive hotbed. I have to admit that. And the reason I say that, I'm going to see if I can zoom in on that. Okay. I don't know if you can actually see that, but the heating elements, you know, are actually right all the way. Let's see if I can see that. Can't quite see it. Okay. Well, on this heated bed, the heating element literally comes out right to the edge. That in itself is pretty impressive. Yeah. Because that means you're going to get heat right out to the literal edge of this entire bed. That is something you don't see even on a lot of your higher end printers. They have a heating element literally right about here. Yeah. And what you don't get is obviously heat beyond the last strip, which is usually a 5mm border around the edges. I'm seeing screws here and no things, so this bed is actually on solid spacers. That means it's going to rely entirely on the bed level system. This is very familiar to me, although in this particular case it looks like it has about, I would say, 1, 2, 3, 4 screws shy of what I usually see. But it's interesting because I can see a hole here, or what could have been a hole, if they had wanted to, and they could have countersunk it, and that would have given it additional things there. Okay, so there is some thermal insulation under here. I'm very pleased to see that. Ah, I see. There are springs under here, so you you ultimately level this. This is still a sprung bed. There it is. That is interesting. That is an interesting design. That could have been done with solid spacers, to be honest. I may change that, because that is actually that is a decent design. But I must admit, that is the first time I've seen one where they have enough room to put additional points and turn it into completely solid spacing, where it holds 9 points on the bed, and I'm betting there's at least a few of you out there who just recognize exactly what that comes from. Right. Bed is about the size of a familiar bed I have, which if this works out, I might actually consider replacing this. Okay, so this bed is 250, 255, 257 millimeters across, and 230 front to back. Yeah. So that is a reasonable build volume, obviously, for something. And I like the way that works, because the strain relief on the back actually centers it right where you need it, pretty much. Okay, so with that in mind, we've got a couple of spots here. So let's see what we got. So according to the instructions, they would like us obviously to put the lead screws, as I said, TR8X8, into the gantry frame. Obviously bring that to the center. There's some screws that put the head onto the gantry. Then enter the lead screws into their receptacles here, and slide the extrusions in. There's a couple of bolts that hold it on either. At that point you turn the printer upside down to do that. Yeah, sorry about the cough there, people. Really sorry about that. I was out doing gardening today and deforesting our back garden full of weeds and tall grass, so yeah, it was a bit of a mess having to do that today. Alright, I'm just going to get these lead screws. Now, I'm not going to take off this packing tape because this is keeping the gantry from dropping drastically fast. Now, looks like you could run this right up into that, so that's nice. I'll just do like that. And I'll do the same on the other end. Now I notice they have a little breakout box here. Kind of convenient because it has all of your connections. So you have a BL Touch 5-wire. Has looks like to be another, I'll have to read what that is. that you have your fan. Obviously, there's another one here. I'm going to guess that this could have had some various upgrades for like the what extruders it does and so forth. So that's not too bad. Now, let's just bring that through. This light. Actually, no. So I will cut that tape now. There we go. A little bit more packing. There we go. Okay, so that's what we got there. Now we slide this down. Run these back up into the top again. Same thing right here. Now, obviously, I'm going to have to find my little thing of super lube in a bit, because I'm going to obviously do that to these. That's very important. Super lube. Feel touch is already assembled. That says Eryone, but that is a very familiar design. I'm thinking that's been sub-licensed, but that means it's going to be a decent one, obviously. So, getting my hands on that, we're going to, yeah, no, see, that is the sign of a really good lead screw too, because that just unscrewed itself right out. So, word to the wise, 2 hands, 1 on each. But this also means that in your slicers, you're going to want to have it never turn off the Z motors at the end of a stop of a print, because there is a chance that the weight of the gantry itself might cause it to come down. Now, they tell you to attach the head beforehand, but I'm thinking instead of setting this thing on its side and doing all of that, yeah, at least get this lined up so that it's sitting correctly. There we go. Now that's that set. Now I can get my rest of the things here where we can work on it. Okay. So I'll put the glass bed over here behind me so that it's nice and safe for a bit. Now, this is fairly straightforward. A couple of screws, bolts right there. Now, I suspect if a person obviously is out there who really isn't overly keen on the design, this is not hard to replace this with a different head. So if you want to do modding on your printer and you have one of these, this looks to be about the same size as an Ender 3 gantry plate. Typical palm wheels, obviously, so it wouldn't be a big stretch or a very large thing to do to change this out for a 3-wheel direct drive. Now, this printer, from what I understand, has sensorless homing. Okay, and what that's telling us is that when this comes across, obviously, and I'll just demonstrate, what it does is when it hits here and it stops, the motor will obviously draw a little bit more current than when it's moving. Obviously, because of that, the drivers will pick that up and say, oh, I've hit an end stop. Yeah, same thing for your y-axis and obviously z-axis motors. And I'm just, yeah, I can feel a little bit of a dimple right there, so I'm probably going to need to adjust the eccentric nut a little bit, because that means it's just a wee bit too tight. We're getting like a valley. These are the kind of things that you should check. Yep, there's a repeatable. That's a repeatable point. Boop. Little pop. That means this is too tight. But that's probably one of the things that they have one do. If it's a, oh, no eccentric nut. Okay. That I would have a problem with. That is going to cause artifacts. Yeah, see that? Pop. So we have one there. And right there. Okay, so 1 revolution. This is actually a little bit too tight. Now that's down to tightness of these wheels against the gantry. I don't know if that can be adjusted in any way. It does not look it. What I may do is look and see if I have a different bearing that I can, a thumb wheel that I can replace that with. That will loosen that up a little bit. Otherwise, that's going to get changed. So sorry about that, Eryone, but if you're going to use non-adjustable gantry plates where you cannot adjust the eccentric nuts, I have a problem with that, sheerly for the aspect that if you over tighten them, or if the design causes it to be too tight on the roller, then that's an issue. Now I'm going to use these when I put the bed on. These are bed clips, obviously, and you put them on the corners rather than the bulldog clips. Well, that's just me. Now, these will be the ones for the head, I believe. There we go. Just about got them. There we go. Got it. So that looks to be a 3mm tool. Let's have a look. Yep, we're doing good still. So we're just about 30 minutes in to this video, or just under it. So you can see, if I wasn't sitting here yapping my crap, we would have probably already had this built. Bing, right on it. Now, I don't think, let me just double check that. Yeah, okay, I was wrong about the lock nuts, though, because, again, I didn't read. Well, I did read, but I didn't read. Yeah, okay, so those will obviously be just the two little bolts holding that in place. Not the locking washers. Those will be down on the Z-axis. So just big enough to fit through. That's nice. Liking the feel of these tools though. They feel like they're fairly well made. There we go. And it looks like the BL touch wire actually goes in and up out the back, so that's a very interesting way of doing it. It's one of the few times you see a BL touch that has a side mount, because normally they're on the top. So it looks like it's been modified by Eryone for that. Interesting fans on this side for your cooling fan. Most people are used to seeing it on the front. Looks to be a 3010. Yeah, 3010, 3020. Yeah, 3010. This is a 4010 typical blower fan. It does appear to have a very nice fan shroud though, for the part cooling, because it actually has three little points underneath, so it literally makes a three-way nozzle like blowing at the tip of the nozzle. That's actually not too bad of a design. Just gonna make sure that that's tight. There we go. Okay. Now, obviously, because I am how I am, I'm going to make sure that these are pretty much the same once we have these all the way up. So I'm going to run this all the way up. Now this is exactly why they tell you that this has a certain build height. Okay, as you can see, it starts to pinch everything. That's not going to be good, but I'm going to put that right at the very top as far as it'll go. So that's at, in fact, I'm going to set that at 310. And it's 310 millimeter. Now I'm going to hold the lead screw on both sides and get them both straight, because ideally that will help me determine if they're actually acting synchronously, which is important when it comes to Z. I know the main board on these are not true dual Z, where each motor is independently driven by its own stepper driver. Parallel Z works as long as you can fine-tune the V reference, but over time the motors will age and misstep, and what you'll end up with is a gantry that's leaning one side or the other. That's not exactly good for your bed leveling, especially when I'm seeing stuff like this. Now, this is a fixed bed in a way. It just has squishy spacers to give it minimal movement. That center spacer does not appear to have a spring. That's probably good for the purpose of the leveling, but I'm not entirely sure. I think I would probably want these four or more. So that may be a mod that happens in the future. They do appear to have okay, so they don't have spots on the actual carriage for it. But I'm sure something can be accommodated. Right, so on with the build. What are we at? We're at 32 minutes. So we're still not doing too bad. Let's get out our four. Let's lose one of our Z-axis bolts underneath the printer. Why don't we do that? There we go. Problem with small build spaces, people. Wonderful. There we go. Got it. This at some point probably will end up with a magnetic sheet and a PEI. Because glass, as wonderful as it is, can have its caveats. At least that's my personal opinion. Okay. So, there's our four bolts. I'm pretty sure I'm not the only person ever to try and do a build video and end up dropping things a half a dozen times and suddenly feel embarrassed. Because you want people to think you're professional, but at the same point, I think it adds a level of, hey man, I'm human, I can make a mistake just like you can. I started out the same place you did. I made the same mistakes you did. I probably still make the same mistakes you do. But that's just how it goes, isn't it? Okay. Now, so I've got my Z-axis firmly into the chassis. So now I'm going to turn this carefully on its side to install the bolts that hold it all together. That's better. Beautiful. Okay. It goes right on up through there. Now this is interesting because this also kind of secures your bottom accessory panel. So I also see two fans on the bottom. So please operate this on a hard, flat surface. Because if you don't, you're not going to get sufficient cooling to this electronics case under here. If you decide to get an enclosure, please make sure that sufficient airflow is coming underneath your printer and can exit back out. So There's our other tool. Really liking this toolkit, actually. It's going in quite nicely. There we go. So I don't know if you can. Let me see if I can turn this so you can see it now that I've got at least one bolt in. I feel a little more comfortable. So there's the bottom of the chassis. Obviously you got your 2 Z bolts there, 2 Z bolts there. It holds a 2040 extrusion. There we go. You can feel it starting to go into the extrusion. Yeah, it's starting to bite because that pushed that bolt out. That's that one. And I'll tighten it down more tightly once I've got these all in there. Now it says the net weight of this printer, according to the sticker on the back, is 8 kilograms. Desktop space 396 millimeter by 447 by 449. That's actually not a bad footprint. Most people can usually fit that inside of, like, you can see that silvery looking thing over there. That's actually a coffee table that was reclaimed from a local shop that sells secondhand. It was like what you call a secondhand men's shop. And it was, I think it was one he was actually giving away because nobody wanted it. And I thought, yeah. And that one's actually, I had to expand where the legs attach. It was originally 55 by 55 centimeter. Whereas most of the, like your IKEA lap tables that people would use for this, obviously are 60 by 60. Now that didn't feel like it threaded in properly, so I'm thinking that there's a little bit to do with this because of the chassis seems to be grabbing the bolt. Put that down flat. There we go. Let's see if that helps. Oh yes, that's better. Nope, not quite. Not sure I entirely. Oh, there it goes. Yeah, that's feeling more like it should. It's a little tight, but it doesn't feel like I'm cutting new threads, if that makes sense. But this is good also because what you don't want is for this to, over time, vibrate loose. This is why they tell you every once in a while, like maybe once a month, depending on how many hours you print, you might take your printer, out of service and just give it a good look, check over, check all the grub screws, check the belt tightness, check the palm wheels, make sure they're gripping the extrusion, etc. Make the adjustments as necessary. Make sure anything that needs lubrication, like the Z rods, obviously your lead screws are appropriately lubricated because obviously it is a machine, it creates vibrations, things will ultimately start to come loose over time. Now that little pop was obviously the edge of the thing coming close to its stopping point on the inside there, which was actually normal. Here we go. And perfect. There we go. You don't want to over tighten these because if you do, you will end up having a problem later on. And I figure while I'm at it, I might as well have a look. Yeah, okay. Okay, so there's no eccentric nuts whatsoever on this. I don't know exactly how I feel about that, especially not with palms, because 608ZZ bearings are not exactly known for the greatest of reliability. But that being said, nothing stops a person from changing this out with a linear rail. Now, that's that. Now, the last part. This is our little thing for the hot end, as per se. So this says E0. This is marked X. And this is a little 8 connector. I used to see these on the mini ITX motherboards for power supply. It's a little Moax. So let's just see where that is. Why don't we look at the instructions instead of guessing? Okay. Now, there is that. Okay, so I need to be on this side. Here we go. So the 2 extra bolts that were in there are obviously for mounting under here. There is a couple of holes for that spool holder. Now I'm going to probably leave that out, purely because I have a dry box up here, because my average humidity is silly high. So I might just leave that out. But let's have a look at where it is. Sure enough, there are 2 holes right here for that spool holder. And it looks like there's actually extrusion under here. So you might even be able to take that off to utilize that extrusion. Obviously, if you want to, you can utilize it for things like spool holders or various other accessories. That might help, but there's nothing up in here. Let me just see. Oh, that's nifty. Okay. There is a space up in here that's about the size of a 608 bearing. So if you get a 608 ZZ bearing, because I was remembering these are 5mm palms, so these are 605s. But the 608s, obviously, you can use up here on your Z screws if you are concerned with the wobble. There's other solutions, though, that are actually better in that regard. So I don't need to worry about that. And it shows here to attach the wire to the little extruded board. Molex goes on the bottom, so there we go, there's our little thing. So the Molex goes on the bottom, and the connectors obviously right near it. Okay, so that's easy enough. And it says, obviously, according to the cable mark, connect the bus E0 and X. Right. Let's turn this around. Let's get a proper view of it. I like the fact that these all have cable ties on them. So I'm going to guess there's some markings on here somewhere. Oh, I see what they've done. Okay, right. So here's our extruder. And they actually showed a picture. Right, okay. Got it. X bus E0. Right, okay. Now, I actually got this one backwards. So, this is my X, I believe. Yeah, here we go. Let's just get this like this. So here's my X-axis. here is my E0, which is obviously your extruder. And then this handles everything else. Oh, there we go. All black connectors and old man eyes don't always go together well. Careful. There we go. Is that in straight? Yeah. Okay. And is it nice and tight? Yes, it is. It does look to be a fairly decent little machine. Solid, definitely very solid. This obviously looks decent. Okay. So, with that everything in place, where did I put the bed? There's the bed. There's the bed. That will go there, like so. Nice and even. Now this. That's nice because that fits just in where I'd hoped it would. Just enough to grab the edges, but not enough to get in the way of any printable. And as you can see, they still have a border around it in black. That will be your limit, as per se. That is what you might call your printable area. Just tighten that up. Go. Nice and tight. There we go. Yep. Now, obviously, with one like this where you can't really raise it, lower it, one thing you need to keep in mind is if you do actually go to a PEI sheet, obviously that's going to drop this, but it's also going to raise back up the size of your magnet. Now this one, I think I'm going to as well do it here, because we're at the corner. I could probably do that on the end. I think actually that's a better idea. Because what is the predominant direction this bed moves? Forward and backward. So what you want, ideally, see where that lead screw, that bed screw is? Put it in line with that. Now you can't get away with that here. So closest, nearest spot is here. Nice and reasonably tight. Again, same thing here. And same thing here. Now these ones I'm going to slide it carefully back. I don't want to end up generating a voltage. There we go. Right. And I could already see that I didn't get these even with each other. That or one or more of these is not tight. So what I'm going to do also, yeah, I did get it tight actually, but it's obviously not. So I'm going to carefully lower these down. Because like I said, one of the things I like on couplers, and these are actually solid couplers, like the same ones you find on Creality nowadays. I like these better because they don't cause you to offset your lead screw. If you have one of the ones that still have like two grub screws that bite into the edge of it, it's just going to be off center at some point. I think the better way to do this is to go ahead and power this on, home the printer, and then set it according to these measurement marks, which is quite clever, I might add. One of the few I've seen that have this. Now, how we at? We're at 50 minutes, so probably one of the longest videos I've done yet. So apologies for the additional time. Okay, let's boot this bad boy up. Here we go. We have printer. It says it's Marlin 2.0.5.3. I am going to look into seeing that because I spoke with them. It looks like they did put it on GitHub, so it is got the open source for the firmware. This feels like a typical 12864. I like the fact that it asks what language. And there we go. Typical Marlin interface. God, that's been ages since I used to have to do this. Auto home. Now that's interesting. That's a good sign of need of lubrication. That's a very good sign of lubrication needed. And the fact that it may conclude that some of this might not be exactly great. Now, I wonder. No, they only have the bed leveling. Okay. As I thought that might be the case. So, one of the things that, since we already know that this particular printer only has 4 stepper drivers, okay? This means that while those Z motors are dual Z, it does have 2 motors. They are both powered from the same board, yeah? The problem we have is that they may not still be level. Now, this is something I might be able to use. No, it's not tall enough. Okay. So, let's use what's on here. That's high enough off the bed I can get away with this. That's 11. Actually, let me use the bottom side of the thing because I can't actually see that on the other side. I am not entirely confident of that. Let's move the head out of the way. Very quiet. So, now that we got that out of the way, 11, this needs to come slightly up to be right on it. And just to be sure that my eyes aren't going to play up with me, this is probably the best way you could do this. To be sure. This will get you within a few microns of perfect. least as far as gantry leveling. That's one of the other features of Marlin, in case some of you are not familiar with that. Auto Z alignment is what it's called in Marlin. In Clipper, it's known as Z tilt adjust. And it basically, it would measure here, and say, hold on, this one's a bit higher. Let me move this motor to make that equal. Yeah, that is a very important thing when it comes to that. Now, with that, just to help my adjustment that I'm trying to make, I'm going to move Z 1 millimeter at a time until that other motor, there's a split in each one of them that helps me understand where the motor is. Yeah. And I'm actually thinking that's probably the better direction, because this way, hold on to this now. I need the other wrench for this. One of the things you definitely want to do, and this is just my opinion, you do not have to do this. This is entirely up to you. If you want to make sure these motors are always in sync, yeah, either put a mark on the coupler, or potentially line them up where the slot that it grips the actual lead screw is pointing in the same direction on both of them. This will give you a visual guide as to whether or not these motors are in sync, because if they aren't at any point, what you're going to end up with is a gantry that, as I said earlier in the video, is cockeyed, and that's not good. Obviously one side higher than the other, it's going to throw your print off, and since you can't adjust this with bed level screws, if it goes above 2 millimeters, the bed level system is not going to handle it. So, with that in mind, I'm going to also move the 10 millimeter, and I'm just going to run that right up. Alright, 200 is the maximum. But they've obviously set that in the firmware for a reason. This is that reason. Now, one of the things I sat here thinking you could probably do, depending on how you feel about it, you can change how this Bowden system works. Move the extruder, move the path, have this come around the front, maybe. Lengthen it, have it go over the top. That's another option. That one's probably not so smart unless that extruder stays up top. Okay. If that's 200 millimeters, that's very interesting. That's very interesting. Okay. But the whole purpose I did this for is so that I could put a little bit of this super lube right down the lead screw all the way down. And it's a nice little straight line all the way down the side. Yeah? And it doesn't take a lot, to be honest. You just need it to work itself into the lead screw. Now, because this is a quad start, doing it this way, make sure that every single thread path gets some lubrication, because you have 4 that parallel each other. Try to picture 4 pieces of string side by side wrapped around a post. Yeah? If you pull one out, you have a gap. So by doing this, And this is all I used. It's just a little syringe I picked up, and this is actually from those little super glue things that you buy at the local dollar or pound shop. It lets you precisionally put a certain amount on your lead screw. You just run your finger up it, just get it down into the groove so that when this comes back down, it starts spreading that around the entire lead screw. Right, so now we're going to go back up to the top, and I'm going to auto home again. There we go. And that will lubricate my screw on both sides. Not overly impressed on that. I need to figure out why that's doing that. Do that one more time. Move axis. It could be, again, just down to that, but I'm going to check alignment as well while I'm at it. Both of the lead screws do appear to be moving without deviation. In other words, I don't see any wobble on the lead screw. Means they are actually straight. That makes me very extremely pleased. I'm going to put one more run of super lube on that while that's spinning. Now that it's stopped, I'm just going to, down the side still, up to about there. I want to make sure this is entirely lubricated. I know we're over an hour, but these are those things that you just jump right in, throw some plastic on it, it's going to be a problem later. Everybody gets excited when they get their first printer, but some actually take the time to do these. I would encourage that. See, motion, auto home. It's the first time I've seen one that homes at the front left corner. This time I didn't hear it make that horrible noise. So there we go. That is your build of the Eryone ER-20. Now I'm going to need to obviously set up a profile, so obviously I'm going to pause the video and I'll be back with a print. Okay, so another little couple of things to show you. Obviously belt reasonably already tensioned from the manufacturer, so that's good. Thank you Eryone for that. Here's where you hook in a USB cable. This will obviously be used if you're printing directly from your computer, or if you set up Octoprint, or one of the USB cameras that I obviously have recently demonstrated. This is for an SD card, obviously, so if you want to print directly from SD card, this is probably also a requirement if you want to use the power loss recovery. So in other words, where it potentially has a chance of picking up where it left off should the print obviously stop due to power loss. Yeah, just wanted to point that out real quickly while I'm setting up a slicer profile. But just to run through also some menu options I noticed when I was looking at it. So this is a typical Marlin interface. So obviously you have an info screen, which is always useful. That's your main one, as you can see. It tells you temperature of the nozzle, temperature of the bed. Now this is an interesting one because it says temperature of the chamber. I suspect that's down here. I suspect that is your electronics chamber, which is very interesting because they did actually have a setting about this, which I found. So the first thing I'm going to do is go to the About printer. Obviously your printer board info or printer info. It tells us it's Marlin 2.0.5.3. It was made in this firmware was made in 2020 on the 31st of March. Obviously in the Eryone website. Board information, very awesome. This is an Eryone Thinker Mini mainboard. Okay, GitHub, you go here if you want to find the source code, the baud rate that you should be setting in your slicer, or if you have Octoprint or a Mintian camera. So let me get back down there. And then of course your power supply voltage. Yeah, there's nothing selectable beyond that. Thermistors, very useful, especially if you go to set this up for Clipper. This is a Hisense 3950. So this means anything with the B3950 obviously as a thermistor. That means technically this could do up to 300 Celsius. So that's very useful. Get back in there. Timeout's pretty quick. So I'm gonna have to scroll back and forth to keep everything visible. But obviously maximum temperature 275, minimum temperature 5 degrees. Yeah. Runaway watch is turned on. These are not selectable options, this is only information. So your bed, maximum temperature is 110, minimum is 5, thermal runaway watch is watching. Chamber, again, same thermistor, yeah, 3950. Minimum temperature is 12, maximum temperature, if it goes above 70°C and you're inside the electronics box, it's going to complain. So that's probably a good thing. That probably means you have a fan that is obviously not spinning, or that obviously you have it in a chamber and it's gotten way too hot in there for the main board electronics. Yeah, means they're in danger. Yeah. Now, other things that I found that you'll find interesting for those that haven't had silent stepper drivers or obviously done anything with them. You go into configuration, advanced. We're going to come down here to TMC drivers. This means that it has, I believe I read this was TMC 2209s. This is your driver current. Y-axis and Z-axis are both set to 700. This is 700 milliamps. Yeah. Motors themselves are probably good to about 1 amp, 1.2 amp, somewhere in there. Yeah. Could be more because those do look like 4234s. They could be a good up to about 2 amps, to be fair. Same thing with the extruder motor. That is definitely a 4234. I would say this is probably something that you may end up doing this one if the Z motors don't stay in sync. That's one possibility, just so you know. But this is something that you can actually, this is how you set it instead of the old way with you know, a voltmeter and that. Sensorless homing. If you have trouble with it determining that it has hit the x-axis end stop on the left, or the bed has hit the end of its run at the back, this is where you would adjust the sensitivity so that it understands how much hit there is to let it know it's stopped. This is where you would tweak that. Yeah. Stepping mode. Now, stealth chop. Stealth chop makes it quiet. Does not necessarily always give you speed or quality, but it does give it quiet. If you turn these all off, your printer will be the typical noisy printer that most people have heard on the internet in the past. However, the steps are more defined at higher speeds because it can have the current to do it. So you may be able to turn off that stealth chop to be able to run it a little bit faster speeds. Now, I'm not going to go into the menu options for the accelerations, that, you know, and all that just at the moment, but that is something that you may be able to tweak to be able to get some faster speeds than what they tell us. As you can imagine, they have calibrate Z, so that will be useful. but we'll go into all of that once I get a slicer profile set up. Okay, one real quick thing I was going to also show you. I mentioned this during the building, and you couldn't quite see it from where I had the camera mounted, but these are the heating elements on the hotbed. Yeah, as you can see, it literally comes within millimeters of the edge of the bed. Yeah, that is essential when you want to be able to print right out to the edge. So if one was to ever convert this printer to Clipper or wrote your own Marlin, this ability to heat right to the edge of the bed, yeah, let me just align that there we go. You see that? You can see that the heating elements come all the way out, front to back, left to right, right out to the edge of the bed. That is amazing. That makes it very worthwhile. And now my OCD is obviously kicking up because there's a couple of grease marks obviously on the bed. But there you go. I wanted you to see that because that's a very important feature. Okay, this is just a little first print. This is the Eryone coaster. Just a little sample of it printing. A little bit of first layer and second layer as per se showing. Not too bad on the speed. Making a new number plate for the outside of the house. Very nice. This was test object 3. Hey look, it's a squirrel! Ha ha ha. Just a little couple shots of the electronics box. Here's the cooling fan that cools the main board. Obviously that's where it plugs in case you need to know. Nice little shot of the main board, 32-bit, and an extra UART port right next to where the fan plugs in. And thank you for watching to this stage of the video. This part of the video was made a week later after the initial unboxing and building, while I calibrated, made a Prusa slicer profile that works for me. I'll just bring back to the fact that this printer was a gift from Eryone for the 6th anniversary of their company. So thank you to Eryone and everyone there for the free gift. I didn't have to do this video and review, but I thought, you know what, why not? It's a nice little printer from the just looking at the designs, and I thought, you know, there's a lot of nuances from a printer brand that I'm, you know, rather fond of as well anyway, reflected in the build of this printer. So I'm going to go ahead and summarize, but I'm going to focus on a couple of niggles and then of course the positives. So flipping around, obviously Cartesian XZ. One of the niggles I had right in for it, I said it right at the beginning of the video, no eccentric nuts. I mean, the palm wheels were over tightened, obviously by design, because they are at fixed locations. You cannot tighten or loosen them, and there was a little bit of a bump that would first appear right about here, and then again an equal distance. That's because when the wheels are too tight, a bearing will have one spot that it might catch on, like a pothole, and you can feel it as you slowly ride it across. That can create artifacts in your prints as it bumps over that, you know, because the motor is going to force it past it, but it's still going to make a vibration. It's still going to show. And if they're evenly spaced along, you'll know it. It's not hard to fix this. Obviously the spacer, which you can see there, standard 6mm. So at which point you can drill that hole. You will need also a nylock nut to secure the bolt once you have obviously the eccentric nut in there. You will also want to put the bolt the opposite direction, going that way, yeah. And then the nylock nut will be on the side of the wheel. The same thing for the Z-axis. You know, as you can see, this is a little bit loose already. That's not good. The bottom one's grabbing, but this means there is a high possibility the gantry is not level. I haven't run the gantry calibration yet. It does have an alignment, and what it does, like a Prusa, which is what some of the inspiration I've seen possibly used, it runs it all the way to the top until it hits, and then obviously locks the motors and brings it back down. That brings it into parallel, and since it's synchronous, being that the motors are in parallel on a single stepper driver, it means that within reason it will keep it level. But using that method instead of true dual Z, obviously it will go out of alignment over time, especially when the motors power off. Yeah, that's that aspect. You will need up to potentially 9 eccentric nuts and 5mm nylock nuts, because if you put one here, one here, one here, one there, obviously to take care of your Z-axis, these are 4 wheels per bar on the 2020s under here, so 2 of them on the Y-axis, and then of course 1 on the X-axis. It's a total of 9. It is a little bit to do, but if you feel confident enough, that would be a recommended change. And at that point, if you wanted to take it to the next level, you could replace these with polycarbonate wheels, which if you get the tension just right, polycarbonate wheels will keep a much more rigid linear motion across extrusion. They also don't wear as fast. Now, as far as other niggles, sensorless homing. Okay, I'm just going to demonstrate something. This was a niggle because of how far it can go. So I'm going to tell this to auto home. Now, notice how it does it. It knocks it against it twice, obviously to determine where the end is. It does that by hitting the frame here. Now the problem is, what hits it is a little bit behind here, which is the threads for this bolt. That hits across on this, ultimately telling it that's the end stop. And then it kind of moves forward a little bit because it knows, according to the firmware, this is your offset for where the edge of the bed is. Now, I'm going to do the motion here, and I'll demonstrate. Move axis, x-axis, yeah? Now, according to Eryone, the distance I should be able to get is 250mm printable. That means the area that you see here that doesn't have a solid border should be 250mm, yeah? And we're just going to quickly run it up there. There's 200. Now 210, 220, 230, 240. Now this last little 10mm, I'm going to do 1mm at a time. 2, 3, 4, 5, 6. Did you hear that? That was going from 249 to 250. That means I'm missing 1mm of movement. Now, a lot of people will say, that's not a lot of action. And it is aligned over the top of there, yeah? But this tells me that the sensorless homing is triggering too early on this side. Now, the solution for here, this is probably in the right spot, yeah? This lovely little idler mounting plate. And I'm just going to go ahead and tell it to home again, just to get that out of the way. Now, obviously because the nozzle was right on the edge, this is in the right spot. But that means technically this side needs just a little bit of filing, obviously here, to give it 1mm of extra movement. Because otherwise it has no threads for this. Because you can't move this part, it's built into the actual bracket. Yeah, it's physically part of it. Plus it holds your x-axis extrusion. Yeah, there is no way around this other than that. So just modifying that bit there to cut into the metal by 1 millimeter. You know, I would give it, you know, 1 to 1.5. That will give it that extra little space to allow it to, you know, do the end stop at the correct location. And that point you can get your full bed volume right to the millimeter. It's 220 front to back. That seems to be pretty bang on, so no worries there. That was my main niggles. Other niggle, the original firmware would have stopped you at 200 millimeters. Obviously, when homing, you're sitting a 10 millimeter safe zone above, so it's approximately 110. Obviously, where it's at above the frame, which you can see they have markings. Yeah, but one of the beautiful upgrades with the latest firmware, which was dated November 2021, is that the Z-axis got an extra 30 millimeters. Now there's only one problem with that, and I'm just going to demonstrate that now. I'm going to tell it to start going up. So there's the 200, and I'm just going to even this out because obviously the offset makes it a little uneven. So going up to 200 millimeters. Nearly there. Now that's going to stop at roughly the 300 millimeter mark, and you notice the Bowden tube is now hitting the upper frame. Now that, to me, is already a problem, because you can see it's starting to bend a very sharp arc here. This is going to create additional friction during retraction. So if you're trying to print up at this high, you're going to have trouble with retractions getting tighter. Now, because it can go to 230, 220, now that's 220. That's the physical limit. Physical limit, where, you hear that? That's because this is touching at the top. It can't go any further. This is also how the printer does a feature I found in the firmware for align, you know, calibrate the gantry as it's labeled. So realistically, I think that having Bowden with that level of height, this probably needed to come this way, like some of the earlier printer models out there. That means Bowden extruder probably should have been offset back over here, realistically, or flipped around the other way, where you can pinch it from this side but have it go the opposite way. Now, there's a couple of ways of going about this. You can change the extruder, you can flip it around, but obviously these tension, you know, things obviously that release the filament means that they're going to be hitting something over here if you try and turn this extruder around. Yeah. Now, as you can see, by telling it to go to 230 and then obviously now telling it to go down, it now puts a potential danger of running it into the bed as it just did. So that's probably not a great thing that they did that. Needless to say, those are my niggles. As far as the positives, very upgradable printer. I pointed out as part of the build video and the little supplementals that the bed is almost identical to that design used by Prusa. Obviously with the heating element on top, same physical dimensions within you know, a few millimeters. Obviously that's a good thing. The fact that it's on fixed spacers, the only difference here is that they, instead of solid spacers on the corners, they used really high pressure springs, and that's good because as you saw what it just did, it pushed down and there's a little bit of play. Yeah, so that's good for the safety of your nozzle and your hot end to a degree, as well as the glass, to be fair. But Lead screws, obviously they're on couplers instead of being direct shaft into the motors. That's probably a cost saving, but it also means that if anything ever happens to lead screws, you're only replacing those lead screws. These lead screw nuts, I don't know if it costs manufacturing more expensively to use Delrin lead screw nuts, but I would have recommended that over the brass, because it means you're not going to be going through super lube and having to clean it off periodically as part of the maintenance. But obviously, to each their own. That would be one of my other recommended upgrades, but it's a positive thing because it's an easy one. The overall style, like I said, it's very similar. It probably took a lot of inspiration from the Prusa Mark III. So there's a lot of good design here. Upgradability, there's already community mods for the hot end. Obviously, where you can put a V6 or a Dragonfly or the Mosquito, you know, there's a number of different ones. And basically anything that you can make a mount that will go with basically just these two screws. Because behind here, it's just a flat plate with those two screws, and the hot end mounts to the top of the fan shroud. So there's a lot of possibilities there to make adapters for other hot ends to fit on here, and then just adjust your offsets accordingly. BL Touch adapter is available in the community things. I saw a few on printables. So if you damage your original Eryone sensor and you want to go to a CR Touch or a BL Touch or an inductive sensor, there's a number of opportunities there that you can do without having to necessarily change the firmware. Just make sure it's mounted at the correct height. But glass bed, love that texture. Not only that, but it does actually do as it says. As soon as it cools off to a certain temperature, your print pops off. No problem. A lot of the tests that I did with PLA. So here's test object number 2 as it was on the SD card. A nice base mode print. And as you can see, it is pretty smooth as far as overall. Yeah. The one that made me laugh, and I did highlight this one in the video. Hey, look, a squirrel. I found that hilarious. And those who kind of know me on a personal level understand why that's hilarious. But, and that's to do with me, by the way. Needless to say, overall, really decent printer. Still some out there on the market for sale, and not near the price points that they used to be at. There is a few retailers that are still asking a very high number for them. That probably needs to come down, but I've seen at least one that showed it for £100, although I questioned stock level. I'm wondering if they're out of stock at that price. But direct drive, easily done on this. There's already community mods for that. That takes care of your extruder problem. It takes care of the Bowden tube hitting the top, you know, and gives you your full build height right up to the edge. The fact that the Marlin version is completely open sourced, obviously you can download it, you can change it, reflash it, no problem. You do have to flash this one a little bit differently. Even though it has a 32-bit STM processor, you still need to use the flashing tool, but it can be done over USB, not a problem. So that's easy enough. As far as using the existing setup, I still would say change out that extruder with a BMG or a DMG. If you don't want to have to massively recalculate your E-steps, DMG is probably your best solution, because it'll only change a little bit because the gear being smaller. Yeah. BMG obviously is a geared extruder. Average, I believe, is 7:1 ratio, if I remember correctly. So it's going to jump from 93 steps to like 400 and odd on the E-steps. And you can calculate that out. Again, that's something I can put a link if people comment and say, hey, how do you calibrate the E-steps in that regard? I've changed my extruder, or I'd like to just double check it to make sure it's part of my dialing it in. And I can obviously respond with a link to the one I use online. But overall, decent little printer. I would definitely say it was one that did a good job out of the box. You know, and if you find one at a price you're willing to pay, whether you're a new to 3D printing and it fits the budget, or if you are a modder, or tinkerer that wants a project to make a decent little printer that can do all the different material types that you do, this would be the one as one of the possibles out there. It's very simple. The display is a 12864 display with two 10-pin ribbon cables going to the board, so you could even change the board to whatever your favorite is. So if you want to put an SKR3 or the Manta 3 Easy, or something that has 5 stepper drivers, or if you still have an old SKR 1.4 turbo knocking about, obviously drop some 2209s on it, set them to UART mode, drop it in there, and then you can hook the two motors directly to the board and have true dual Z and set up auto Z alignment. It leaves so many possibilities. I'm not going to cover every possible mod at the moment that I thought of, because I've already got a billion of them going in my head. But I hope you enjoyed, obviously, watching the build of this printer and some of the prints that it's done already, as well as listening to my waffling about what I thought about it at the end. So thank you again for watching, and happy printing.